To learn more about earning college credits with Study Hall courses, visit gostudyhall.com or click the link in the description. Decisions. So many that could go wrong. Life is full of choices, and it's pretty useful that computers can make decisions that can help us out, like deciding which movies I might enjoy or which route I should take to the airport. But although computers can make decisions, we need to tell them how to do that, which essentially comes down to getting computers to evaluate statements as true or false, kind of like having computers work through yes or no questions. At first, it might seem like we wouldn't get very far with just two options, but we can break down so many complex decisions into much smaller questions that computers can work through. When provided with the proper information, computers can make decisions efficiently and accurately in a way that we just can't, and that makes computers incredibly useful. In fact, the ability to make a decision based on provided information and a set criteria is arguably the source of most of the power of computers. And when we can tap into this power, we can use it to solve all kinds of problems. Hi, I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. When it comes to making decisions in our lives, the set and forget strategy can work wonders. By making a decision ahead of time and not worrying about it until later, we put ourselves at ease with the knowledge that we've taken care of things. The problem with set and forget is sometimes we're a little too good at the forgetting part, which reminds me that I forgot to defrost dinner. Guess I'm eating a frozen lasagna. My friend Fred also tends to forget things, and that's caused him a panic attack or two. You see, Fred runs a luxury dog walking service, and he sets up a schedule of which dogs he walks on particular days. But he often forgets to check this schedule, and sometimes misses picking up a pooch he's supposed to. It's only when he feels like one of his fine furry friends is missing as he's strolling in the park that he checks his schedule and ends up scrambling to pick up the dog he's forgotten. To avoid this kind of thing, Fred wants a program that will tell him the names of the canine clients he'll be walking each of the 3 days of the week he works as a dog walker. For example, if it's a Tuesday, the program should print out, "Good morning, Fred. Today we'll be going on a stroll with Gertrude, Archibald, and Yoda." That means at least to start, the computer needs to know what day it is so it can decide which dogs Fred will walk and give him that list. Maybe that sounds easy, but we're starting small. Then with just a couple of building blocks, we can create programs that make all kinds of decisions. Remember, computers are just tools. They're powerful, but they rely on instructions from us. So to get started, we need to think about the problem that we're trying to solve and what decisions are involved. One way to do this is with a visual tool called a decision tree, which is a diagram that shows different decisions with their possible outcomes. Designing decision trees is a great way to conceptualize how to break down even the most complex of ideas into a series of simpler decisions. For instance, in order for Fred to know which dog to walk, we'll want the computer to decide what day it is. So on our decision tree, our first decision is what day it is. So obviously we have 7 options. Under each box labeled "Is it Monday?" or "Is it Tuesday?" and so on, we'll draw 2 arrows in either direction. These arrows will point to the action the computer should take depending on whether the answer is yes or no. For example, the "Is it Sunday?" box should have an arrow that points to the action we want the computer to take if the answer to the question is yes. This box should say something like, "I have the day off, so the computer doesn't need to print anything." And it should have another that points to the action the computer should take if the answer to the question is no. This one should say, "Is it Monday?" Because we'll want the program to ask another question and continue asking what day it is until it arrives at the right day. For each decision in this diagram, the possible outcomes are represented as branches. The branches we choose depend on the yes or no answer we give to certain questions. Since it's impossible for the questions we're asking to be answered with both yes and no at the same time, we can only choose one branch per decision. For example, if we're deciding which branch to take based on the question, "Is it Tuesday?" we can't take both the yes and no branches because it can only be Tuesday or not Tuesday. Once we've sketched out the problem and the decisions are clear, we can think about how it can be translated into code. Let's start with an overview so we know where we're headed. First, the computer needs to know what day it is, so we'll have Fred input the day of the week. Then we'll need the computer to make a decision about what dogs to walk, and it needs to output or print that information for Fred. To actually have the computer decide which dogs will be walked, we have a few options, but one of the most basic building following blocks is an if statement. An if statement is code that will tell the computer to run different blocks of code depending on whether a set of criteria or condition is met. Those blocks of code are called branches, and they're kind of like the branches of a decision tree. Although they're very similar, there is a key difference between our decision tree and this kind of code. Our decision tree used yes or no questions, but when we code with if statements, we're working with statements that will be either evaluated as true or false. That might sound a little complex, but if statements basically follow the same logic we use all of the time. Like when I'm ordering groceries on an app, I'd say, if the store has sour gummy worms, I want a bag of those. That basically means that when it's true that the store has gummy worms, that's what I want. An if statement can also be partnered with an else statement. Else statements basically tell the computer what to do when all of the conditional statements before it are false. So for my grocery order, my full request could have a logic along the lines of, if the store has sour gummy worms, I want a bag of those. If not, or else, I'll take sour gummy bears. Whether or not the store has at least one bag of sour gummy worms is the condition. Now let's take a look at how we would structure if-else statements in Java in terms of my grocery order. We'll get back to Fred soon, I promise. Although we're focusing on how if-else statements are structured in Java, they're a construct that shows up across programming languages. In Java, there are some specifics that we follow because of the syntax requirements. The condition we're interested in is encased in parentheses, and here we want to know if the store has one or more bags of sour gummy worms. In Java, the greater than or equal to operator is represented by the greater than symbol followed by the equal symbol, and works just like the greater than or equal to symbol that you're used to. So if the condition evaluates to true, there is at least one bag of sour gummy worms, then the following block of code will execute. If the condition evaluates to false, the following block of code will not execute. We see in the first line of code that the variable sour gummy worms has been assigned an integer value of 0. In our online grocery order example, this would mean that the inventory count for sour gummy worms at the store is 0. In the next line of code, we have our if statement with the condition, if variable sour gummy worms is greater than or equal to 1, then the phrase I get sour gummy worms should be printed. But since this condition is false, the computer moves past the block of code associated with that if statement and onto the else statement. Now that we've gotten a handle on how to set up if and else statements, we can introduce the else if statement, the final concept we need to write Fred's program. In the grocery store example, we only tested one condition. Is there at least one bag of gummy worms at the store? But sometimes we need to check more than one thing, like in Fred's case, where we have to check if it's Monday, Tuesday, or some other day of the week. That's where the else if statement comes in. It lets us test multiple conditions and only executes the code when the previous conditions are false. Alright, let's take a look at some code that old Fred might find helpful. Now, based on our sketch and the power of if statements and else statements, we're ready to craft Fred's program. First, in order to start making decisions, the computer needs to know what day it is. Fred might be forgetful, but he does usually know what day it is. Or at least his phone does, so we can have him input that information. Now you might ask yourself why Fred's inputting a number and not the actual day of the week. That's a totally fair question, but we're trying to keep things simple. To make a program that would take the names of the days of the week as input, we would need to cover a concept that we don't have time for. In Java, programs take an input using a scanner, which we talk more about in our episode on inputs and scanners. This first segment of code is just prepping the program to receive input from Fred. Then the next line of code prints the message asking Fred what day it is, and we store his answer in a variable called day that we can use later in our code. Now here comes the if statement. We need the computer to make a decision based on what day it is. Let's say it's Tuesday. That means Fred enters 3. The computer has to check what Fred entered against what it's supposed to do for each day. And a quick note about Java syntax, the equality operator or the two equal signs are used to see if two things are equal. The result will be true if the value on the right-hand side is equal to the value on the left-hand side of the operator. But when we're assigning a value to a variable, we use the assignment operator, which is just one equals sign. So Fred entered 3 for Tuesday, right? We check that with the first if statement, which only evaluates to true if he enters 1 for Sunday. Since it's not Sunday, we move on to the next condition with an else if statement. The next else if statement checks if the day is equal to 2, but it's still Tuesday, so we move on to the next one. This one checks if the day is equal to 3, which it is, so the computer prints out, "Good morning, Fred. Today we will be going on a stroll with Gertrude, Archibald, and Yoda." All the following else-if statements will not execute because it's Tuesday and therefore it isn't any other day. Plus, in this case, we don't even need an else statement since we've already accounted for all of the possible days of the week. And just like that, Fred has a program that solves his forgetfulness problem. Though our program for Fred is a simple one, it's a key milestone in our programming journey. We learned how we can use code to show a computer how to handle certain conditions and make decisions. That means we can eventually write programs that allow computers to make very complex decisions that would be incredibly challenging for a person to make. An exciting example of this is the potential for computers to take on a greater role in diagnosing medical conditions. With the right data and responsible rollout, a computer could recommend options based on symptoms and justify them with similar cases it's seen before. Then, a medical professional could use those options to make diagnoses more accurately and efficiently. This could mean that communities with only a few medical professionals could have their health needs better met and improve patient outcomes. But no matter how we use it, the ability to make decisions based on criteria makes computers incredibly powerful tools for problem solving. If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, check out gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.